All right, fifth graders. This is going to be a lesson where I'm going to try to combine all of the concepts and ideas from the last handful of days and try to hopefully do my best to make this a little bit more understandable for you. I do know that this is a challenging lesson, and there's been a handful of us who've gone on to Think Central and done the practice problems there, and I thank those individuals for doing that. I cannot promise how long this video is going to end up being because I do want to make sure that I cover everything and that I hit kind of the high points and the things that I hope will help you to make this a little bit more understandable for you. From the exit tickets and from the amount of Zoom requests that I've gotten from this lesson, I'm definitely grasping that you guys are struggling with this concept as a whole. And how we would basically describe this lesson, fifth graders, is ratios and proportions. Okay, so the biggest thing I want you to grasp and understand about a ratio is that it is very similar to a fraction, very similar in the way that we deal with them or how that we should view them. So you're going to see here that we have multiple ways. In fact, in this first problem here on the board, we can see that we actually have, let me expand this a little bit just so we can bring it up and I can draw on it easier. You can see that we have this ratio of 2 parts kiwi fruit to 3 parts strawberry juice, written kind of in 3 different ways. All right, and I think this lesson, first of all, wanted to introduce the concept of tape diagrams, and I'm not saying that tape diagrams are a bad thing, but I think the 6th grade teachers, as we've discussed it, I think the introduction of 3 types of ways to solve these problems and the fact that we aren't in a classroom to really gauge your face-to-face expressions has kind of been a difficult aspect for us. I think it's almost too much information. But this diagram or this example right here is what we consider a tape diagram. Okay, so hopefully from that picture you can see where the 2 and the 3 are coming from. All right, so you can see that we've got 2 liters of kiwi fruit and 3 liters of strawberry, or 3 groupings, excuse me. 2 parts kiwi fruit juice and 3 parts strawberry fruit juice or strawberry juice. So that's where those numbers are coming from, but that's not the important part here. The important part is really the labels and the ideas. Okay, so as we look at this, we are seeing that they're telling us the strawberry here, this bottom 3 boxes, needs to contain a total of 15 liters. All right, we need to get that to be a total of 15 liters, and because of that, all right, we need to figure out what each of those boxes are going to hold, what each of those parts need to be. Well, this should be a relatively easy division problem. When we look at 15 divided into 3 groups, we should know that each of these is going to be 5 liters. Okay, so not a difficult task, and because of that, then we should also be knowing that these boxes, that's one of the reasons the tape diagram works so well, is that these boxes need to be equal to one another. Okay, if we're dividing something, and fractions are the same thing as dividing, if we are breaking these things into equal parts, that then the 2 boxes on top of kiwi fruit also need to have 5 liters in each of them. All right, and then that gets us to our number of kiwi fruit total, which would be 2 5s or 10 liters. And that's how they want you to kind of look and view those tape diagram questions. All right, hopefully that registers and makes a little bit of sense. We can also then represent this as a factor puzzle, which is something we've worked on literally this entire year, and that's one of the reasons I think we talked about it when you guys were here with us. We talked about the fact that these factor puzzles are going to be important all year. That's why we kept bringing them back and why we really wanted you to understand the concept of them. All right, now where the 2 and the 3 came from is, again, back to this original, our unit ratio. Okay, our basic ratio, the smallest, simplest fraction we can put together is 2 to 3. 2 parts kiwi fruit, 3 parts strawberry, that's where that is coming from. Now we want to determine if we have a mixture that has 15. Now this is what we consider a part-to-part proportion. We are not going part to whole, we are going part to part. So if the part of strawberry is 15, there's again multiple ways even with this factor puzzle that we can look at this. You can see the S is indicating that we're strawberry here. You can see that we're indicating kiwi here. You can see that this is unit right here. Okay, this 1 right here shows us that this is the unit ratio. So now we are simply either completing it as a factor puzzle, looking and placing the numbers on the outside edge, or we can simply look at how did we get from 3 to 15. Now this doesn't work every time because sometimes that number ends up being a decimal number or a fraction number because it doesn't go in evenly, but in this case it does go in evenly. So fairly straightforward as to how we can use this. So 3 to 15 means we multiplied by 5. Same thing up on top here, multiply by 5. So we should know then, and again we should see here that our answers of 10 liters are the same in these two scenarios. And that's going to be the same when we put this into an actual proportion. And this is a proportion right here, guys, where we see kind of two fractions, and we're looking to, again, create equivalent fractions. So I can look at these two very easily and determine that, yep, how'd I get from 3 to 15? I multiplied by 5. How'd I get from 2 to x? I multiplied by 5, which then again makes x a 10. Okay, but what happens when these things don't go in nice and easily? Okay, this is where our cross multiplication idea comes into play. All right, and this is why we set this up earlier and trying to make these things happen. And again, it doesn't matter which way you go with it. Whereas when we were comparing fractions earlier, we wanted those numbers to indicate which was larger. Here we want these numbers to indicate which are the same. There's the equal sign right there. We want that to be the same. So as we look at this, 3 times x equals 3x equals 2 times 15. I'm not sure why I'm using the times sign as an x, but that's what I've got there for right now, just so we can represent that. So when I combine that, this then becomes 3x equals 30. Okay, we need to isolate the variable. It's been a long time since you guys have heard me say that, but that is again what we are trying to do here. How do I isolate the variable? How do I get rid of anything that's on the same side? I have to do the opposite or inverse action. So if I'm multiplying x by 3 here, I need to divide by 3 to get rid of those. These two things cross each other out, so it leaves x on a side by itself. But to remain equal, to keep it an equal and balanced equation, guys, we must do the same thing to both sides of it. So as I now look at the other side, I also need to divide by 3. So 30 divided by 3 in this case is 10. And guys, right there are 4 different examples of how we get to the answer of 10. Okay, and in the long run, guys, I don't really care which method you choose or how we get to that point as much as I do picking one and feeling confident in it. Yes, definitely the proportion method is going to be the quickest. That's what we'd like you to get to, is our little 2/3 equals x over 15. But in all honesty, if a factor puzzle works for you, if a tape diagram, go with what works, especially early in this process. All right, I'm going to skip ahead a couple of pages here because those are the same types of questions here. Now, I'm still going to go ahead of this as well. Now, this is where a lot of us have I've noticed the struggle start to begin. All right, and that is, guys, that we are talking about, let me scroll up here a little bit more so we can see the title, part to whole. And this is where the terminology and the verbiage needs to take place. We need to wrap our mind around where these numbers came from, what we are labeling here, how these things all work out. And I know Ms. Lundstrom went through and did a very good job of explaining, but maybe hearing it a second time and getting these things in your head will make more sense. We are still dealing with the same exact question we started with on that first page. 2 parts kiwi fruit, 3 parts strawberry juice. So it is the exact same ratio. Notice again, we are dealing with that right down here in our tape diagram. But you also should notice that we are identifying a different thing that was not in that first tape diagram. Okay, we are now identifying that we have a total of 50 liters there. Okay, so that's where we get to a different ratio. We are not looking for, well, how do I make this into 15 if I've got a part-to-part relationship? What if I've got 15 parts of strawberry juice? How much kiwi fruit juice would I have? No, now we're looking for, if I still have the same ratio, 2 to 3, 2 parts kiwi fruit juice to 3 parts strawberry juice, what is my numbers? What are my numbers going to be when I want to get to a total of 50 liters of this mixture, not of one part or the other? So notice again that I'm not, when we get to the factor puzzle, using the 2 to 3 ratio. Okay, I'm using 2 to 5. Well, where does the 5 come from? The 5 comes from adding my 2 parts together. 2 parts plus 3 parts gets us to 5 parts, and that is where our number comes from. And that seems to be the biggest struggle at this point. Okay, but here is where we need to start reading these questions. We can't just look at numbers and start throwing them into these formulas and these situations. It says how many liters of kiwi fruit juice, okay, so that's a part. Kiwi fruit juice is part of the mixture, should be used to make 50 liters of the kiwi berry juice. Okay, that is the combination of those two things. Here's kiwi fruit. I'm not a huge fan of the terminology and the wordings. Maybe we should change it to kiwi fruit and strawberry and then total juice. Let's just change it from kiwi berry to total. Okay, to total juice, the mixed juice. Okay, that's where we are not going part to part. We're not going kiwi fruit to strawberry ratio anymore. We're going from kiwi fruit to the total mixture. All right, so keep that in mind as we are going forward with this problem. There's with those numbers, and that seems to be the biggest thing that I'm noticing people struggling with on these problems, guys. All right, so as we look at this now, guys, as we look at this problem, okay, we now look at this and we need to get to a total of 50 liters. All right, we still have 5 parts. We still have 1, 2, 3, 4, and 5. I don't want to write in the boxes just to make a mess, but we got 5 of those things there. So if we've got 5 parts of anything broken into now a total of 50 liters, how much is each of those parts going to be? Again, still the division aspect. 50 divided by 5 is going to get us, so instead of it being 5 equal parts, it's going to be 10 in each equal part. Okay? That's the difference here. It's not 5. Originally it was 5 because we weren't concerned about the total amount of mixed juice. We were just worried about part to part. Okay, so we had to start with that original part of 50 liters. We want to bring that back. Now, how many parts of that then are going to be strawberry juice in that mixed combination? It's going to be 30 liters. How much is going to be the kiwi fruit? It's going to be 20 liters. And again, notice that the 20 plus the 30 equals our 50, and that's where those numbers are coming from. Okay, so again, if any of us, if all of us get to a point where we can identify, guys, what the numbers are and what kind of problem it is, we're going to put ourselves in a successful position, because once we get to put the right numbers into these ratios, into these proportions, we get the right idea. Now, how do we get from 5 to 50? We multiplied by 10. Same thing on the top, multiplied by 10. So again, now we're getting to our answer of 20 liters. 20 liters. This one is also going to be 20 liters, and here is why. How did I get from 5 to 50? I multiplied by 10. How did I get from 2 to x? I also then have to treat it equally. Multiply by 10. 2 times 10 equals x equals 20. Or if I do the cross multiplication method, which again is where we're trying to get you eventually to. Okay, 5 times x is 5x. 2 times 50 is 100. Divide both sides by 5. Get rid of the 5's here, which means I'm isolating my variable of x. Get an x drawn here, that'd be great. Okay, x equals 100 divided by 5, which again gets us to 20. But I'm going to say that it's not our struggle with with the process, guys, as it is as much about understanding where the numbers are coming from and how are we getting to these numbers. All right, I'd like to wrap this video up here shortly simply because we are having issues with length, and I don't know if we can all stay focused on this. So I'm going to cut this off, and I'm going to make another video